Hey guys, here we are to, I guess this is probably going to be my last video. So I'm going to try to cover the rest of the questions on this test. I'm going to maybe go through them a little faster than I have before. All right, so we left off question 18, so now we're moving on to question 19. In an upflow furnace, the heat exchanger is located where? Below the blower, beside the blower, above the blower, or in front of the blower. This is kind of a tough question too because it really depends on the type of furnace. So it's an upflow furnace. So if you guys remember, an upflow furnace is one where the supply air is coming out the top and the return air is coming in from the side or the bottom. So if this is a typical like gas-fired furnace or electric furnace or something like that, the fan sits at the bottom, and if it's a gas furnace or whatever, the heat exchanger is going to be right above the fan. If it's an air handler for a heat pump, quite often the A coil that's built into the unit will actually be on the bottom, and the blower will be at the top. So the heat exchange happens down below the fan. So it's kind of a loaded question. They don't give enough information to really give an accurate answer on that one. So, but I think typically they'd probably be looking for above the blower. Since this is a refrigeration course, I would be saying below the blower. But even then, if it's a retrofit, it could be above. So it's not a great answer or not a great question either way. But I've shown you both answers that would work for it. So I guess you learned something anyway. A lowboy configuration is best suited for installations where headroom is no concern, in attics, in basements with low ceilings, and or in crawl spaces. So a low boy, if you remember, is the one where it has the return air and the supply air both on the top. And in the video yesterday I said it's perfect for low ceiling heights. So that one's going to be C, or in basements where the ceiling is low. Question 21. Which type of air handler has the return air entering the top and the supply air leaving the bottom? Again, from that video yesterday, the counterflow or downflow furnace is the one where return air comes from the top and supplies out the bottom. Yeah. All right, question 22. What type of unit has no flue and is 100% efficient? That's one thing I didn't really talk about is efficiency. So typically, if we go back to a furnace, if this was a gas one where the heat exchanger is here and we had that blower down at the bottom, a gas furnace or an oil furnace or something like that is going to have an exhaust. Like there'd be a flue that goes up to a chimney, and when that heat exchange is happening, the air blows by, the fuel is burnt, and then waste is going up through the chimney. Part of the heat is actually escaping up the chimney as well, so that is not 100% efficient. I'm like probably in the 80s and early 90s, some of the gas furnaces that we were installing had like an 85% efficiency. So you'd have quite a substantial amount of energy escaping out the chimney. Now with high efficiency gas furnaces, you can get them where they're 95 or 98% efficient. So very little wasted energy is happening. But the most efficient furnace out there is an electric one. Because 100% of the heat exchange that happens travels down the ductwork and through to the registers. Now, don't confuse efficiency with expense, because an electric furnace is definitely the most expensive to run, because an electric furnace has usually a series of 5 kilowatt heating coils in there, and they are ridiculously expensive to run because you're using up electricity and lots of it to heat your house. So, but most efficient, definitely electric. Sorry about the puppies barking, but we have puppies right now. So furnaces are sized according to BTUs. So you know, this one has amps, tons of heat, CFM, and BTUs. So furnaces are going to be sized according to BTUs per hour, because that's how the heat loss and heat gain calculations are done. And then when it's if it's a heat pump or something like that, then it would be converted to tons of heat, or if it's electric, you'd convert it to amps, or watts. But it's definitely going to be BTUs. And then depending on how many BTUs or tons of heat or cooling, that's going to determine how many CFM there are. So that one's D. Selecting the size of a furnace for a home begins by, I've already said this a few times, determining the heat loss for the house. Most residential systems are extended plenum. I think on the very first video I showed you guys this typical extended plenum. You know, there's these other ones like reducing trunk, radial, and closed loop, but extended plenum is the right one on that one. And that's just where the furnace has a supply plenum, and then it has the main branch that comes off and then feeds all the different rooms. So that's a plenum, and the ductwork that comes off it is technically an extended plenum. A furnace which has both the supply and return on the top of the furnace is a low boy. I've already talked about that one a few times. When changing from a rectangular to round duct, the round duct size should be what? So this one I haven't really talked about yet. So the options are an area 3/4 of the trunk size, B is the largest size that will fit, C equal in area to the rectangular duct, or D determined by using a ductilator. Usually when I read this out, people laugh at the last one. They're like, ha ha ha, ductilator. That's actually the right answer. Because you don't want to use equal area. If you guys remember me talking about the friction loss, you know how the air sticks to the sides of ductwork. If I have a square duct and I add up all the perimeter of it, that's a lot of surface area for the air to stick to. If I have a round duct, the perimeter or circumference of that round duct is going to be less than an equal area size square duct or rectangular duct. So to find out the proper equivalent size, I'm going to be using a ductilator. So it's a sheet metal worker way back when designed a, it's like a scale, a sliding scale ruler that will determine what that equivalent round size would be for the square size. All right, moving on. Negative pressure in a furnace room can result in what? So this question definitely has to do with a gas burning furnace again. So back to my picture here, which is very scribbly now. If this gas furnace has a chimney that goes up and out the building, this question has to do with gas furnaces, and it has to do with old inefficient gas furnaces. So an old style gas furnace would be considered a naturally aspirating appliance, which means that it has what's called air dilution. So when it's burning the fuel here, hot air rises and goes up the chimney. If I had just a solid chimney going from this, when that hot air rises, it starts to create a negative pressure in there, and it's kind of like sucking through a straw with your finger over the end of the straw. You can only suck for so long, and all of a sudden the straw starts to collapse on itself, and air doesn't move through it. So in order for this to work properly, they'd actually have an open area here, which would allow air from the room to travel up in there and help that hot air rise up the chimney. If you had a negative pressure in your building, so in a house, if you had your dryer running and your bathroom fans running and the range hood running, you can cause a negative pressure in your house. and that negative pressure can be enough where it would actually draw that poisonous gas back down into your house and potentially kill people. So that's called backdrafting. Higher efficiency furnaces now have a completely sealed unit, so they bring in their own fresh combustion air from outside and exhaust directly to outside, so there's no concern for negative pressure. But anyway, the answer on this one, negative pressure in a furnace room can result in flue gases being pulled into the return air ducts. So that's definitely the right one there. These next questions have to do with a duct hanger chart. So I think I'm actually going to skip those because they're not really applicable for you guys. So that's pretty much it. Hopefully you got some good information out of this, and hopefully it helps with your refrigeration career in the future. If you guys have any questions, you can feel free to call me or text me, and I'll be happy to answer them. Anyway, good luck.